Example 3 is now talking about systems of equations that are 3 by 3, so 3 variables, 3 equations. I would pause my video, watch theirs on Savas, and then we can try the next example together. So pause me and then come back. So first thing I notice here is you got 3 equations. If I just combine the a and the b together, the y's are going to eliminate. So that's what they do first here, is 3x plus 2z equals 8. And then what's happening down here for the f equation is they multiplied the second equation by -2 and combined it with the c equation, and that also got the y's to eliminate. And what you're left with is that. So now what you've got is a d and an f equation where both the y's are gone. So now it's just a 2 by 2 system. So what they do is they then take that d equation, right, and then combine it with, well, multiply it by 2, and then combine it with the f equation. The point of doing that is to get the x's to eliminate. 2 times 3x is going to be 6x. That'll eliminate with the negative 6x. What ends up happening also, though, is 2 times 2z is 4z, which eliminates when you add it with negative 4z. 2 times 8 is 16, minus 10 is 6. So you end up with 0 equals 6, which is a false statement. So that's why this is going to have no solution. All right, let's take a look at a couple of you try questions. So pause it and then come back. First thing I notice here is if I combine the first and the second equation, x plus x is 2x. Y plus negative y is nothing. Z plus z is 2z. And then 3 plus 1 is 4. If I combine, I also want to figure out a way that I can now get the y's to eliminate and incorporate the third equation. So I want to combine the second and the third one. When I add those together, x plus x is 2x. Negative y plus y is 0. Z plus negative z is 0. And then 1 plus 2 is 3. So actually this is even better to get both the y and the z to eliminate. So now I can just take the blue equation and solve for x. So x is equal to 3/2. And then I'm going to substitute that in and solve for z in the red equation. So it would be 2 times that 3/2 plus 2z is equal to 4. 2's cancel there, and you have 3 plus 2z equals 4. Subtract 3 on both sides, you get 2z is equal to 1. Divide both sides by 2, and you get z is equal to 1/2. All right, still need the y. Just pick one of them, doesn't matter. I'll take the first one. So x plus y plus z equals 3. All right, so my 3/2 I'm going to substitute in for x. My 1/2 I'm going to substitute in for z. And we'll solve for y. So you have 3/2 plus y plus 1/2 is equal to 3. 3/2 plus 1/2 is 4/2, which is 2. So y plus 2 equals 3. Subtract 2, you get y is equal to 1. All right, so your ordered pair at the end, I'm sorry, your ordered triple is 3/2, 1, 1/2. Right, and then you can go back and substitute them into all the equations to make sure it works, right, as a check. Well, if we add them all up, you do get 3. 3 halves plus 1 half is 2, minus 1 is 1. So that looks like it's good. And then if you have 3 halves plus 1, that's 5 halves, minus 1 half is 4 halves, which equals 2. So that seems to check out. All right, let's clear all that out, and then we'll do the last one here. A little more complicated looking. All right. So I think the first thing I'm going to see here is that I can get the y's to eliminate by adding the first and the third together. So if I have 2x plus y minus 2z equals 3, I'm going to combine that with the third equation, which is 3x minus y plus 5z equals 10. Again, I'm choosing to add them together because the y's will eliminate when I add them together. So what I'm going to end up with is 5x, y's eliminate, plus 3z equals 13. Now let's figure out a different way to get the y's to eliminate. I'm going to combine the first and the second equation to create another one. The reason why I'm going to do that is I've got a positive y there, I've got negative 2y there. I'm just going to write it up here. So you've got 2x plus y minus 2z equals 3, and you've got x minus 2y plus 7z equals 12. I'm going to multiply the first equation by 2 in order to get the y's to eliminate. Rewrite that down here. So now I've got 4x plus 2y minus 4z is equal to 6. Now when I combine them, I get 5x. Y's eliminate. Plus 3z. That's equal to 18. So now now I have two equations with an x and a z that I can combine. What jumps out at me right away is that the x and the z's are the same, but then the constant is different. So what will end up happening is I'm just going to multiply one of them by -1. You could also just subtract. I always multiply by a -1 and then add. It just helps me not make a mistake with subtracting. But when I combine these now, x's eliminate, z's eliminate, so I've got 0 on the left side. 18 plus -13 is 5. So that means it's no solution here. Okay, doesn't matter what else you do. It's a no solution. All right, let's take a look at example 4.